Alright, so let's get Python installed in our computers here. So let's come over to python.org up here and go to the download section. Now, before we actually do this, you might want to check your computer and see if you already have Python installed. So you can come over to terminal over here and you can just type in Python and -v like this. And as you can see, I already have Python on this machine and it's 3.7.6. But you just want to make sure you have something over 3 for this little mini course we're going to be doing. Anything Python.2 could be a little bit different, so I would suggest using that. So if you do not have anything showing up there, let's come back over and go to this python.org/downloads, and you can come in and you can see right here we have download the newest version of Python right here. Now this is for Mac for me, but if you are using Windows, there's also a Windows distribution there. We got Linux and all different types of stuff. So come in and download that. And then again, if you're on Mac, you could also use Homebrew. Come in and install Homebrew like this. And then to use Homebrew, you would just come in and say brew install, I think, like that. All right, so that is good. All right, so once you have everything installed there, let's come back over to our terminal here, and I've just created a folder called Python course, and I've CD'd into it, and then I am just gonna open this up in VS Code. All right, so I'm using VS Code. Feel free to use whatever text editor you want, but if you are using VS Code, I would suggest coming over to these extensions over here, and you want to make sure you have the Python extension. Yeah, this Python extension here, and it's from Microsoft, and it'll just give us a few more things with text highlighting and whatnot. So a bunch of good stuff. So I would install that, and yeah, once you're done that should be good. All right, so next let's come in here and let's create a file. So if we want to create a new file in Python, we're just going to go like this and say we'll just say test.py, and then we have a Python file all ready to go. Now let's go over some of the data types that you will see in Python. All right, so here we have the different data types that you'll see in Python here. So let's go over them real quick. So an int is going to be like 2 or whatever, 10, anything like this, any number basically. We'll come down to our float here, and a float's going to be a decimal, so 2.3, whatever, 4.3, whatever you want for that. Then strings are going to be in quotes here. So we'll say test, anything in quotes like this. A list is going to be like an array in JavaScript, so you're going to go square brackets, and you could have like some array of numbers basically, and they call them lists in Python. So a list is just going to be like that. Then we're going to come down, and a dictionary in Python is the same thing as like an object in JavaScript. So that'll be like curly braces, and then we'll have some sort of key. So we'll say key here, and then that will be have some sort of value, just like this. And again, you could have a bunch in a row. All right, let's go over, this is tuples here. So a tuple is going to be an ordered immutable sequence of items here. So that would just be like, say we have a number, and you could have, again, some sort of string in here. And then you could have, say, a float, just like this. Now the difference is with this cannot be changed, the order here. This is immutable, meaning we cannot change the order. All right, that's good for that. And then let's go on to sets here, and these are unordered collection of unique objects. So a set, the object has to be unique that you put in. So for instance, we cannot go like 1, 1, like those are not unique, so that would not be allowed. But we could have whatever, 1, 2, whatever, keep it going. Or the same, you could have strings and stuff too. So test, and that would work fine. All right, then finally, we just have a Boolean here, a bool, and that is just gonna be your typical true or false. All right. All right, so these are gonna be the data types that we're gonna use, and we'll get into using these throughout the course. But for right now, let's just give you a taste of how to do a few things, maybe with some strings or some numbers. So we can get rid of this here, and then we're going to come up to the top. And let's first show you how you can print something to the screen. So in order to do that in Python, we're just going to go use the word print like this. And then let's do a string. So we'll just say test here like this. And if we go ahead and save that, we can open up a terminal in the bottom here. And with this open here, in order to run this, all we have to do is say Python, and then we'll say test.py, which is the name of the file. And as you can see here, it runs test, which we have printed to the screen. So if you have Python 3 and Python 2 installed, you may have to run Python 3 test.py, just in case that wasn't working for you. All right, so that is our string here. And then let's check out numbers here. So in order to actually comment something out, we can just go like this and add this little hash sign. And then if we want to use numbers, let's go like this, and we can print this out, and we can just say print 1. If we run that again, and if we run that, we'll see we get the 1. And then you can just do like addition, subtraction, all the different mathematical operations. So we could say 10 times 10 here, or just like this, and save that, and then running that. You can see we get 100 just like this. So any of the mathematical operations here, we can go plus, we can go minus, we can go division, and we can do the modulus operator as well. So that is all good. Now, if we wanted to put these in variables here, let's come down here. And in order to do a variable, we don't need any like const or var or anything like that you might have in JavaScript. You're just going to write the name of the variable. So we'll say test like this, and that is going to be equal to, say, 10. And then we can come down below that, and we can say print test like this. And we should, if we run this, get the value of 10. Just like that. And yeah, so that is how variable assignment works in Python. All right, so in this video, we're going to be talking about working with strings in Python. So let's get right into this. I just have a open file right here, and we're just going to go through some different string methods and kind of how you can work with everything to do with strings in Python. So let's talk about initializing a string. So let's go ahead and say we have a variable here. And we'll just call it name here, and that will be initialized either by double quotes in Python, but you can also use single quotes, so that doesn't matter. So let's start with double quotes here. So we'll just say Darwin like this, and that is how you are going to initialize your strings. Now, if we come down here and we wanted to do a multi-line string, that would be done by triple quotes here. So we go like this and come down here like this, and then in here we could have a multi-line string. So we could say Darwin, and down here we could say tech like this, just like that. And then I'm just going to run this. This is going to open it up in kind of a live code in the right side here. So we can say the name here is Darwin, and that is that. Now, if we wanted to switch this, let's go like this. Comment this out for a second here, and we'll just say name is equal to this. And then you can see that you're going to get this new line character. So if we want to print this, just like that, you can see they're going to end up on different lines. So that is the triple quotes right there. So let's come back like this. We'll get rid of that, bring this back here. So another thing, not necessarily to do with strings, but just a little something here, is if we want to initialize a variable, we can also do them on the same line. So we can go like this, A comma B, just like that. And then we can set them equal to, say, we'll just say test and variable, both strings, just like this. All right, so now this is the same thing as going like this. A is equal to test, and B is equal to variable, That's the exact same thing as this. So that's just something to know for you. All right, let's get rid of that now. So let's get into a few more things we can do with strings. So let's say we want to get the length of the string. We can just go like this, and we can say print, and we will say len. So that is how you get length. And then we can just say name like this, which is our variable up here. And we can see the length is 6 over here. So that is great. So you can get the length of that just like that. Then if we wanted to get a particular index here, we can come down here and we can say print like this, and we can get the name, and say we want to get the first item in this Darwin string here. That's simply just like 0. So this is kind of the same as like JavaScript. You can just put the index of whatever letter in your string you want. All right, and then if we copy this down here, we can also see that we could go from the other side. So we can get negative indexes here. So let's say we wanted the last item. If we go -1 here, we can see we get the n from Darwin. So, and you can go from the other way. So -2, you would get the I, -3, and so on to get the W. So that is how you can work with negative indexes right there. Now, some other things we can do. Let's say we want to print out the name, but we want kind of a segment of the string. So we can go like this, and we can go 0, let's say 4. And we can see we get the first 4 letters of the string. So this is gonna be you're starting where you want to start the segment. And then the 4 is going to be up until that number. So we're going to go 0, 1, 2, 3, and then up until the 4th. So we don't include that. Now, we can also go like this. Let's copy this down here. And we can omit this 0, and it will just start at the first or the 0th index and go up until the end. So you can see that these two are going to be equivalent, just like that. Now let's come down again. We'll copy this down one more time. And we can do the same thing with the end. So if we go 0 and then we omit that, you can see we go 0 all the way up until the end of the string. So now let's just comment some of these out for now so we don't clog this up as much. We still have that name. All right, so now let's talk about escaping characters. So let's say we have a full underscore name like this, and this is going to be our variable, and we will say Darwin Tech, just like this. And we want to come down here and print the full name, just like that. We can come over to our C. We have our Darwin Tech right here. So what if we wanted to escape a character here? So say we wanted to have a double quote inside of here. So normally we can't just add a double quote like this, or we'll see this will break. So if we want to escape that character and actually allow it, we can go / like this, double quote. And then if we come up here, you can see now we have this double quote in there. You could also just come in and do just a single quote like this, just like that, and that would also work. However, you might want to stay consistent within your like double quotes and everything. So that is one reason you might want to use the / there. All right, and then close, get the double quotes back. And then if we want to do a new line, that's going to be \n. And you can see that will also put us on separate lines. Now, the triple quotes will do that too. And you might want to use that instead just for formatting, so you don't have a bunch of \n's everywhere. Okay, so that is looking pretty good. Let's get rid of this for now. And we'll come back down below that. And now let's talk about concatenating strings. So let's give us a couple variables here. So we'll say first, and that will be equal to Darwin, like this, and last, and that will be equal to tech, like that. And then say we wanted to concatenate these into a full name variable. So again, full name like that, and that's going to be equal to first. And the original way you might be doing this is you're going to go plus, and then in between, you can have a space there, and then we're going to do another plus here, and then last. So this is traditionally how you would concatenate things. So let's just print that out so you can see what that looks like there. Full name like that. come over here, and we can see we have our Darwin Tech full name. So this works fine. You can do it like this, but in more recent versions of Python, there's also the something called f-string. So how we're going to do that is we're going to come here. We'll just comment this out and come down here. And let's say we want to have full name again like this. Now we can go like this and we'll say f. And then inside of here, we're going to have our string. And then we're going to open up some curly braces here like this. And we can add whatever we want for our variables. So this will be our first, and then we're going to have a space here. And then we're just going to have last like this. Now this and this are going to be equivalent. So if we come over here, we see we still have the Darwin Tech like that. So some advantages of this f-string kind of syntax here is we can actually do all types of expressions within here. So we can do mathematical calculations. So let's say we had, let's just go like this, and we'll say math is equal to f-string. And then inside of this f-string, we'll just go 2 times 2 and close that off. And then print math here like that. And you can see we get the 4 just like that. So that adds a whole new level of functionality within our strings, which is pretty good. All right, so that is a lot of string stuff. The last thing I want to go over is all the different built-in string methods. So let's get rid of this here. Let's come down to the bottom, scroll up a bit. And I'm just going to go through kind of a ton of these. So let's say, actually, let's keep this full name here. We'll keep this here, and then we'll come down here, and we'll say print, and we'll say full name like this. And the first thing we're going to look at is transforming this into uppercase. So in order to do that, you'd come in here and we'd say dot, and you can see all these different things, replace, lower, all these different split, all these different methods pop up. And the first one we're going to look at is upper. And when we call that, we can see we uppercase our entire string. So let's copy this down and show you a few more. We can say lower like this, and we will lowercase everything like that. We can title case stuff. So title like this, and you can see if we come back over, it's going to be, this is going to be the same, but if we come over here and lowercase this and come back up, so now our normal string will be lowercase, but when we title case it, you can see it comes back up. So the titles will be uppercased, or the title letters rather will be uppercased. Let's copy some more down, keep this going. We can also capitalize like this, and you can see you'll get the same thing, except for this is one string, so our second word in this string will not be capitalized, but our first will. So just like any sort of capitalization you would imagine. And then we can get into some other things like strip. So this will take out the white space from our thing. So right now, if we add that, you can see, let's come back up. We'll change this back to capital. And let's imagine we added a bunch of white space, or we don't have to imagine, let's actually add the white space. And then come over here, and you can see that all of these now have a bunch of white space, except for this one, which has stripped away all of that extra white space. So that's kind of a useful one you might use a lot. What else we got? We can split. So if we go like this, we can split this up. And inside this split, we want to show which item we want to split it at. So this will split things into an array of strings here. So since we have all this, we're getting this, but let's get rid of this extra white space. And if we come back, we can see that now this is split into a list, or an array in JavaScript, but a list in Python of our two individual strings. So that's what split does. Let's keep going, a couple more. We'll say we can go find like this, and say we wanted to find a particular part of that string. We can say dar, the first 3 letters, and this will tell us if this is in our string. So for us, 0 means it is, and then -1 will mean it isn't. So if we go like this, now we're getting -1, saying that this dar-e is not in our string. All right, let's talk about a few more here. We got, we'll go replace, just like this. And let's say we wanted to replace the D in Darwin with a lowercase d, like this. Now we come back up, and we can, oh, we spelled replace wrong. Replace like this. We can come and see that this has been replaced. Our uppercase D has been replaced with our lowercase d. So that is great. Now let's check out another one here. So let's print out, and we're gonna see if Darwin is in full name, which is our variable. So if this is in that, we can see that it is. Now if we are to get rid of this or change it up, and we can see that it is false, it is not in full name. So this is checking if a particular string is in the other string. Then we can also add on here the not function, which is kind of the negation operator there. And so if it's not there, which is true, so let's say we go back here, Darwin like this, come back, and if it's not in there, this should be false, just like that. All right, so we'll go over tuples later on, but I just want to show you this because it kind of has to do with strings here. So my tuple like this, and that is equal to, we'll say Darwin, and the second item is going to be tech here, just like this. And then let's say channel, and that's going to be equal to, and we're going to say a dash here. So this is going to be what we're going to join on, and then we'll say dot join. And then in here, we pass in that tuple or tuple or whatever you want to call it. So that is my tuple. And then when we come down here and print that, channel, and then we come over and see what that looks like here, we can see that we're joining these two strings here, or these two items in our tuple here, and we're joining them with a dash. So that is what dot join is going to do for us. All right, so that is a lot about strings. Hopefully that's helpful, and thanks for watching. See you in the next one. In the last video, we showed you how to set variables with strings. Let's do that with numbers here. So let's just say we have a as our variable, and that's going to be equal to 5 like this, and then we'll just come down below here and we'll just print out a. We can go and we can see that that shows our print output like that. All right, so let's talk about some of the different things we can do with numbers. So they have all the arithmetic operators, which I think we went through most of them, but let's just cover those again. So let's come up here and we'll give ourselves a little space here. And we'll just say a is equal to, and we'll say 20. And then they have all the different arithmetic operators. So we got plus, we'll say plus 5 for this. And we can see we get 25 like that. Now let's copy this down a bunch more times, and we'll just go over the other ones. So of course you have minus like that. And then if we can comment these out at the same time, we can see we get the minus. Then again, we can have multiplication just like this, comment these out, and you can see we get 100. That works. Let's go back here. Just regular division like this. Okay, and we get 4.0. So you see we're going to get a decimal there, a floating point number. And then there's a few other ones. So these are kind of the main ones that we've gone over here. Now let's talk about some of the other ones. So we can do integer division, which will divide the left by the right, and it's only going to keep the whole number component. So let's show you what that'll look like. So let's bring this back, and that's going to be done with the double slash here. So you can see we only get the whole number here, but let's change this over. So right now we're getting the same value basically, but imagine we have a different number here. So let's just go like this, and we'll say 8 divided by 3 like that. So you can see we get the output of 2. So 2 times 3 is going to be 6, so it goes in only twice. So it's going to be only the whole number component left over. All right, and then again, I think we might have gone over the modulus already, but let's bring it down again and see it one more time. So let's say we have modulus operator being used. So let's do a different one. We'll go 10 divided by 3. So 10 by 3 is going to have 1 left over. So we're going to have 3 goes into 10 3 times with a remainder of 1, and that's what we have there. So I think the only one we got left over here is going to be the power of. So if we went 3 star star 3, that's going to be 3 to the power of 3, which would be 27. So those are kind of the arithmetic operators we're going to work with, and that is basically all of them. All right, so we're just going to come in here and get rid of some of these here. Comment them out, and then we're going to come down, and another thing I forgot to mention here is that we can work with binary numbers here. So let's say we went a is equal to 0b101 like that. That's going to be 5 in binary, so we can actually work with those, which is kind of cool. So if we come down, we can come down and say print, and we'll say a like this. And you can see we get 5 just like this. We already have that. And then if we want to get the binary of that, we can say binary, bin, like that. And we get the actual binary number back when we do that. So that is pretty neat. We can actually work with the binary numbers. And then the last thing that we can work with is hexadecimal. So let's come down. Don't need this. And we'll just say b is equal to 0x5. This is a hexadecimal number here, and we'll just say print b. So you can see that is 5 in hexadecimal there. And then if we want to get the actual hexadecimal again, we can go like this, say hex, and close off those brackets like so. All right, and you can see we get this hexadecimal value back. Okay, so we'll comment these out too, come down again here. Now let's talk about some number functions here. So let's say we have c is equal to 2.6, we'll say. And then below here, we're going to look at some of the different methods we have available to us. All right, so with these number functions, we have a few different ones available to us. And we're not going to go over all of them, but we'll just test out some of them. And I'll leave a link in the description for more of them. And the first one we'll print out will be round. So that will round our value, and we'll round that c value there. And you can see here, if we scroll up here, it's going to round this 2.6 to 3 like that. So that's round. We can also get the absolute value. So if we print out the ABS like that, and we'll say c like that, and we get the absolute value. Now, if we change this to a negative here, you can see that it still comes back with a 2.6, which is the absolute value of this negative 2.6. All right, so we'll bring that back there. Next, let's just look at the assignment operator here. Let's say we got c, and then that is going to be equal to c, and we'll say plus 2 like this. And we can come down and print that. Print c like that. And if we come up to the top, you can see it's just going to add 2 to our number, which we would expect from this. But with our assignment operator, we can also go like this and go c and say plus equals. And we will say 2 like that. And you can see we get the same 4.6 if we do that. So this and this are equivalent. So those are the exact same thing. And unlike JavaScript, we don't have any increment or decrement operators. So if we come like this, we can't go like C++ or C minus minus. Those aren't available to us in Python. Now let's comment some of these out here, and we'll come up here. And we have a bunch of other functions available to us in a library called math that we're going to bring in. So this is a library that we have to bring in. So we're importing math here. And then we'll come down and we'll use some of these to test things out. So let's actually bring this variable back. So we'll have our c of 2.6 there. And then we'll come down here and we'll say print, and we will say math dot. And you can see on this side, we have available to us all these different functions here. So let's start with one called floor here. So we'll go math.floor, and then we'll pass in that c that we have created up here. So when we do that, it's going to round down to 2. So that is what we get with floor. Let's copy this down. And we can do basically the same thing with seal, which is going to be like ceiling. So rounding up to 3 basically. So those are two kind of round functions. So then, like we had this absolute value here, we can also call one called fabs, F-A-B-S, which is going to return a floating point no matter what. So this will show this 2.6 no matter what. So if we change this to, let's just change it to 3, it'll be 3.0. So it's going to return a floating point, unlike this absolute value here. So let's create a new variable here, and we will say d, and that's going to be equal to, we'll say 9. And then we'll come down here and keep going with some of these, and we'll say math dot, and we can go square root. So that's sqrt, and we'll pass in that d there and show you how this looks. And then if we come over, you can see that we get this 3.0 because the square root of 9 is 3. So that's square root. And you can see, say we change this to 10, we'll get a decimal instead here with some numbers. So this is the square root here. All right, so let's come down, and there's a ton more. Let's just show you, we'll show you one more just to show you some of the power in some of these. So let's say print, and we'll go math dot fsum, and this is going to sum up all the numbers in a sequence here. So we can pass in a sequence or a list in Python here. So we'll go 1, 2, 3. We'll go just random ones like this, and then you can see this is going to print out the sum of all of those. And we get 19.0. These all summed up. So in JavaScript, this would be, you need to use something like the reduce function and add those, but this is just nice in this math module here. So there's a ton more. There's trigonometric functions, etc., logarithms, just a ton of different stuff in this math module. So definitely check it out. All right, so in this video, we're going to cover conditional statements as well as going over how type conversion works in Python. So let's get into it. I guess let's actually cover type conversion first and just go over that quickly so you know how that works. So in Python, the types won't be automatically converted. So we got to do it ourselves. So we'll go like this. Let's say a is equal to, we'll say 10 right now. So that's the number. And say we wanted to convert that to a string. We could go like this and say print. And then in order to convert that to a string, we go str like that. And then we can pass in that a like that. And then that will be converted to a string. Now these will look the same, but this is now a string. So now let's copy this down a few more times and see how we can convert to some other types here. So imagine we wanted this to be a float. We can just go like this and say float like this. And now we can see that our value is a float. So that works for that. And now let's bring this back. And what if we wanted it to be a Boolean? So we can go bool like this, and that's going to be true. Now, this is only true because the falsy values in Python are going to be 0. They're going to be empty string like this. They're going to be the none value, or they're going to be an empty array. So those are going to be all of your falsy values. So if it's not one of those, which for us it isn't because it's 10, it will be true. And that's why we're getting true when we convert it to a Boolean like so. All right, so the last thing that we can do for type conversion is we can convert it to a an int. So let's bring this here and we'll just go int. Now it's already an int. So let's imagine we turn this to a string like this. Now we can convert it to an int like that, and we get 10. All right, so that is all you need to know about type conversion, or at least enough of what you need to know about type conversion. So let's go like this and comment those out. And now let's handle conditional statements. So in order to do this, I think the best way will just be to go over an example here. So let's start with a count here, and we'll just say that is equal to, we'll say 12, like this, just a random count. And like a lot of languages, we can do an if statement here for our conditional. So we'll say if count is less than 10, and we're going to do a colon like this, and that's how you do it in Python. And then we'll just print out, and we'll say count is less than 12, like that. All right, and then that should work for us. All right, so you can see here we're not getting anything. But if we adjust our count here to be less than 10, you can see now we get the printed message. So this is how a conditional will work in Python. Now there's a couple other parts of this that we can add on. So we can add something called an elif, like this, and that's going to be your else if statement. And we can say count is equal to, we'll say 8 right now. And then again, the colon, and then come down and we can say print count is equal to 8, like this. And count is equal, we'll change this actually to 11, and we'll just change this to 11 just so we can see that. And we can see count is equal to 11, like that. Okay, so that's our elif there. And then finally, if we come down here, we can do an else to cap things off. And we'll just say print count is, we will say greater than, and for this we'll say 12 like this, and we will say 13 is our count. All right, so that is how we're going to do our conditional statements. So that is pretty good. I think that covers most of it. Let's comment that out right there. Come down below here. And the kind of last thing I want to cover here is the logical operators. So the logical operators in Python are and, or not. And these allow us to work with conditional statements in interesting ways. So let's cover some of that. Let's come down here. All right, so with these logical operators, we can do stuff like this, where we say if count is greater than 10 and count is less than 20. So greater than 10 and less than 20 is going to be between those two. We can say print, and we'll say count is in between, like this. Okay. And then if we come down, we can see count is 13, so in between 10 and 20, and we get the output we'd expect with count is in between. All right, so that is good. Now imagine, let's come down and do another example here of the not operator. So not in JavaScript and stuff, we just use the bang. Here we can use the actual keyword not. So let's imagine we have an is available, like this, and that's going to be equal to false. And then we come down below here, and we can do another conditional if statement where we say if not is available, like this, and we will print is true, and then else we'll print is false, like this. So because we've added this not keyword here, we're getting is true, because we're saying right now this is available is equal to false, so not false would be true. So that is how that is going to work. Then finally, the last thing we'll do here is we'll say if count is equal to what do we put count, 13, like that, and we can use the or keyword like this, or count is equal, we'll say we'll just say 14 for now. We will print out count is 13 or 14, like that. And you can see up here, if we scroll up, count is 13 or 14 because this condition is true because our count is 13. So it's one of these. So if it's either of these, we will be able to print out this statement here. All right, so that's it for conditional statements and logical operators and type conversion. See you in the next one. So Python has two types of loops. There's for loops and while loops. And in this video, we are going to cover the for loops. So basically in for loops, you can iterate over either strings or lists. So let's start out with a little example here for string. Let's say we're going to go like this and say for I in Darwin, like that. And then we will just do a colon like this, and then come in here, and we're just going to print out the I. So each letter in here is going to be our I in this string here. And then we're going to print out each individual one like that. And you can see when we do this on our right hand side, we are printing out each item in this string, each letter there. All right, so that's pretty basic there. Now let's say we wanted to do the same thing, but with a list here. So let's say we have some items like that, and then we want to loop over this array or a list in Python of items here. So again, we say for I in items, same syntax. And again, the colon. And then again, we can just print out the I like that. All right, and then if we do that, we can run this again. And we get the same thing down here. You can see the 1, 2, 3, just like that. So whether it's a string or a list, it does not matter. We can loop through them with this for I in items type syntax. All right, so that is great. And the last thing, let's comment some of this out here. The last thing we want to just cover real quickly here is we can also loop over a sequence of numbers with a little bit of a different syntax here. So we can go like this, and we can say for I in, and we can say range like that. And then let's say range 10. And again with the colon, and then let's print that out one more time. I like this. So this is our syntax, and then we can run this. And we can see we get from 0 up until 9. So the range of 10 will be include the 0, but up until the 10th value, like that. All right, so that is what we'll get with range. Now there's a couple other things we can do with range here. So we can add also a first and second item here. So we'll go 5, 10 like this, and we can run this. And now 5 is where we're going to start, as you can see on the right here, and again up until that 10th number right there. All right, so that is good. And then finally, there's one more item that we can add, and that, let's see how that works. So we can add 2, say here, and we'll go ahead and just run that again. And now we get every second item. So we're going to go by 2s up until that last number there. So that is basically the for syntax in Python. So one other thing to keep in mind, it might be useful, is that the range right here, this is not actually returning a list. So this is not actually a list in numbers. It's going to return a range object, and that is actually unique from lists. It's just a different kind of data structure that's very memory efficient. So just a little tidbit, probably won't come up too much. Might be something good to know just in case it comes back and bites you later. All right, so that is the for syntax for loops. Next time, I guess we'll look at the while syntax. So thanks for watching. All right, in the last video, we went over for loops, and now let's talk about while loops here. So let's just get right into it here. Let's say count is equal to 1. And then we're going to come down below, and a while loop is going to look like this. So we're going to say while, and we'll say count is less than 10. Colon like that, and then we're just going to print out count, and then below that we're just going to go count is plus equals 1. So this is the syntax right here. So we're saying while the count, which is currently 1, is less than 10, we're going to print out the number like that, and then we're going to add 1 every time we loop through this. So this will continually loop until this condition is met. So if we save this and run this, you can see on the right hand side, we're going all the way up till 9 there. Okay, so that is your basic while loop. All right, so let's try out a little something else here. Let's keep this, and we'll also add an if condition. So if we come down below here, we'll say if count is equal to, let's say 5, like this. Then we're going to break. So if count hits 5, we're going to actually break, and it'll actually stop running like that. So let's go ahead and save that. And then again, we're going count plus equals 1 outside of this. So if we run that, now you can see once we get to 5, this actually breaks and stops this while condition. Okay, so that is the break command there. Now let's try one more thing, which is the else command. So we'll get rid of this if here. We can actually add an else clause here. So we can go like this, else, and we'll say print, and we will just say count larger than 10, like this. So let's run this again. And we'll see it down here at the bottom. It prints out count is larger than 10 once this condition is no longer met. So this else condition will only run if we're out if this condition, this while condition, is no longer met. All right, so that's all while loops really are. Pretty simple. So now we've done for loops and while loops. And in the next videos, we should be getting into a little more complex, more interesting stuff. So stay tuned. All right, let's get into functions in Python. So functions are pretty straightforward. We're going to start over here, and we're just going to say def, and that's going to be our keyword, which is going to tell us that a function is about to be declared here. So let's say we have a function called add, like that. And we're going to say it has 2 parameters here. So we'll just say a and b, like this. And then we're just going to have a colon. And then down below here, we're going to say return, and we'll say a plus b. And that will be our entire function. So then we come down here, and we're just going to print out add like this. And we'll pass in, let's say, 4 and 5. So we'll go 4 plus 5. And then we'll call this. Now, we have to make sure we have the return keyword here. So let's run this first and show you how it comes up. So we see we get 9 over here, which is the correct answer if my math is right. And now if we take away this return, though, you'll see that we will not get anything here. And you can see we get the none here. So we have to make sure we're returning something every time from our functions. Okay, so this is the basic syntax of a function, and then everything else is just kind of an add-on to that. All right, and we can also set a default value. So if we wanted b here, just to have a default of 5 like this, we can come down now, and we don't actually need to pass this in. So if we go ahead and save that, come back here and run that, you can see we get the same answer. So that is one way to do that. So this is our basic syntax for functions. Let's show you a little more stuff we can do with them. So we can also come in and say, we'll just go again, def add, and we will pass in here a star and then items. Now, this is going to allow us to not label how many items we necessarily have. So here we're passing in 2 parameters. This is saying we're not actually sure how many params we're going to pass in here. And then we can do something like this where we say count equals 0. And then if we want to iterate over this, we'll say for I in items. The items right there, and then we will go count plus equals I, and then we will return here. If we go back and we'll say return, and we'll say count like this, and go ahead and save that. So we're iterating through this time. So let's run this, and you can see we get 4. So we're getting 4 because there's just one iteration right now. So let's come down here and actually pass in, let's say 4 again, we'll say 6, we'll say 7, and save this and run that again. And now you can see we're getting 21. So right here, we're adding the each item onto the count each time. So it starts at 4 here and then adds each next value as we go, and we end up with 21. All right, so that looks good. Let's come down and show you one other thing before we end this, and that's gonna be that we can create a Python dictionary with a double star syntax. So if we were to go like this and say def person, like that, and here we're gonna go double star like that and pass in the info of that person, and then again a colon, of course, and then here we're just gonna return the info like this, and then here let's come down again and we'll print out this time, we'll say person like that, and then we're going to pass in different values that we want for our dictionary. So let's say first name underscore name like this, and that is going to be equal to Darwin. And then our second value is we're going to say last name, and not going to be Linux, but we'll say last name is equal to tech like that. Okay, and then if we scroll over here, let's give ourselves a little room here so we can see the whole thing. So all we're doing here is we're going to be able to pass in and create a dictionary, key value pairs, and they're going to add them. And that's what this double star is going to do. So now when we run this again, you can see, I'll just comment this out also, but you can see here we're getting a first name Darwin, last name Tech, and that's in a Python dictionary like that. Now, one other thing we can do here is if we were to come up to here, our return statement, and instead of returning info, we can actually get a certain item. So if we were to say info again, and then we passed in here, and we said we just wanted to get the first name, like that. Now this will return our first name for us. So let's run that. And you can see here we get Darwin back. So that is how functions work in Python. Hopefully that was useful, and I'll see you in the next one. All right, so let's talk about scope in Python. So let's start by defining a function here. So we'll say def my name underscore name like this. And this will be our function, and then we'll come down below here and we're going to set a variable. So we'll say name like this, and that's going to be equal to Darwin, string of Darwin. Okay, and then below that we're just going to return name, and then below that we'll come down here and we'll say print, and we will say my name like that and call it. Now if we save this and go ahead and run it, you see we get Darwin in our terminal to our right here. Now, this is what we'd call local scope. So it is local to this function, and it will only be recognized within this function. Now, if we want to set some global scope, which is our other type of scope, we can come up here and we can say name, and that's going to be equal to, we'll call it something else. We'll say Nick like this, and then we'll come down here and we'll just comment this out and go ahead and save this. And now this will return from our global scope. So if we run this, you can see we get the name Nick like this. Now, what happens if we have both of these like this? So let's comment back in this name variable of Darwin. And now we have two variables with the same name. And when we run this, you can see we'll get the one within the local scope right here. And then if we come down below here and we say print, and we'll just say name like this, we want to print out this variable, and we'll run that. So on our right hand side here, we get Darwin and then Nick. So we're getting the function my name here, which is returning name, which has this in the local scope. And then the name variable we're getting from the global scope out here. So that is basically how local versus global scope works in Python. Thanks for watching. Let's talk about Lambda functions. So what is a Lambda function, or also a Lambda expression, you might hear them be called? So basically Lambda functions are going to be anonymous functions that can be passed to other functions. So what does that mean? Well, basically a Lambda function is just going to be like any other normal Python function, except for that's going to have no name when you define it. And it's also going to be contained into one line of code. So that's kind of the differences with a Lambda function. Now, let's just go through and show you first. Let's show you how just we'll define a normal function. So we'll say def, and we'll say full name like this. And we'll pass in two arguments here. So first and last. So we're going to get the full name. And then we're going to return here. And we will say first, and we'll say plus here, and then we'll do a space, and then plus here, and we'll say last like that. So this is just kind of a basic full name function. And then we come down here and we'll just say print like this, and we will pass in the two different variables into our full name function. So we'll say full name like this, and then we'll pass in our first, which we'll say is Darwin, and then another one, which will be our last name, and we'll say tech like this. Now, if we save that and then we run it, you can see over on this right-hand side, we get the Darwin tech. So this is our traditional function, how it is normally done. Now, with a Lambda function, this can be shortened up quite a bit. So let's comment this out here, and we'll just come down below here and show you how this is done with Lambda syntax. So first of all, the Lambda syntax is going to be like this. So we're going to say Lambda like that, and that's going to be our keyword. And then you're going to have an argument or arguments, either one. And then you have a colon and then an expression. So that's the syntax for a lambda function, just like this. Now let's fill this out. So for us, we're going to say a lambda like this, and then we're going to pass in our first argument here, and then we're going to have a second one. So you have multiple arguments here after the lambda. You don't just need to have one. And then we're going to have our expression after that. So for this expression here, we're just going to say first, and then again plus, and we'll go like this, and then another plus, and then last, just like this. So these two, this one and this one, are going to be basically equivalent. Now right now we have no way of calling this, so we have to assign the full name to it as a variable. And if we save this and run it, you see we get the same result. So those two are equal. But basically this isn't helping us too much. So let's look at a more real world scenario where we might use this. So let's get rid of this here and here for now, and then we'll come down below that. And let's do a more realistic. So let's add, let's say we have a list here. We have a list of nums right here, and then we come down below here, and let's take a look at how we might use this lambda function. So one of the ways we might use these relatively often is through the different built-in Python functions like filter and map and all the different ones. So let's try this out with filter. So let's say filtered underscore list like this, and then we're gonna get a list here, and then we will pass in the filter like this, and we're going to actually go through these filters and stuff, but basically what filter is going to do is filter through a list and determine based on some criteria that we're going to say whether the items stay in the list or not. So we have filter, and then for this filter we can pass in a lambda here like that, and we'll just say lambda, and we'll say x for now, and then we're just going to say if x is greater than 5. So we're going to filter through all of these and see which ones are greater than 5 there. And then after the 5, we're going to have a comma like this, and then pass in that list of nums, just like that. Okay, make sure everything's closed off, and let's give ourselves a little room here so we can see the whole thing. So this is our filtered list, and we can just pass in this lambda function right here like this. So this is a more realistic use case. Now, if we come down below here and we say print, and we'll print the filtered list like this, go ahead and save that, and then we'll run it. And you can see we get 8 and 6 because those are our two numbers that are greater than 5 in this list. So that is a more real world scenario where you might use a lambda function, but basically anytime you want a one-line anonymous inline function, you might want to reach for a lambda. So thanks for watching. I'll see you in the next one. All right, let's go over the map and filter functions in Python, and then we're also going to be talking about list comprehension and show you how that all works. So if we're over here in our terminal and we come in here, and normally if we wanted to loop over, let's say we had an array of numbers. So here we have an array of numbers, and normally if we want to loop over them, we do something like this. So we'd say for n in numbers here, like this, and then we could do some sort of action like say print, and we'll just go n plus n like this. So this is traditionally how we would loop over these like this, and then we run this, and then you can see we get these printed out to the screen. But we can also use something called map, which we're going to show you how to use in this video. So let's comment this out for now. So in order to use map, we're going to have to first pass in some sort of function as the first argument, and the second argument is going to be our list of numbers over here. So let's come over here and show you how it works. So let's say we have a function here. So we'll say def like this, and we're just going to say double nums like that. And then we're going to pass in a num like that. And then we're going to return here. And again, we'll do the same thing. So n plus n like this. Okay, so this is our function here. And we come down here. And now if we want to use our map function, we can go like this and say result like that. And then we can say that is equal to map like so. And then here we're going to pass in as our first argument that function. So that's double nums like that. And then for our second argument, we're just going to pass in those numbers like this. Okay, so now we can come down below here and we're just going to print out that result like so. And we can save that. And then we run this. So when we run this, you can see we get this map object. Now we can go like this and we can say list to turn it into a list like that. And then go ahead and save that and run that again. And then you get this list back, which doubles each of the numbers in our list, just like we would expect. Okay, so that is looking good. And now if we wanted to do this kind of, we worked on lambdas last time, so let's actually show you how this might work like that. So we can come in here and we'll comment this out. And then we'll come down again here and say result. And then we'll say that is equal to map, just like that. And then here, instead of using this function up here, we can pass in a lambda. So we can say we can say map here, and then we can say lambda, and then we're going to say n like that, and then we'll say n plus n like that, and then that is going to be our lambda function. And then again, we can just pass in those numbers like so. Get rid of that, and we can save this. And now we're going to run this one. And you see we get this map object. So again, same thing. We can change that into a list. We can do that down here too in the results. So we can just turn it down to a list down here like that. And we can save that. Run that again. And again, we get the same result. So that is how map works. Now, we did go over filter last time, but let's show you how that works one more time, just to make sure it is clear. So filter is going to be similar to map. It's going to loop over all our items, and then it is going to perform some sort of action to see if the item should stay in the list or not. So let's go like this, and we'll say filtered nums like that. And that is going to be equal to filter like so. And then let's just do a lambda like this. And then again, we're going to say num like that. And then num, if it is greater than or equal to 2, it will stay in the list. And then we'll just pass in again that array or list in Python. So let's close this over a little bit so you can see the whole thing. Okay, so this is what our entire filter function is going to look like here. And then we can come down here and we can just print that out. So let's say print. And again, we'll say list, and then we'll say filtered nums like that, and save that. And let's run that. And again, we are going to return all of the values that are over 2 or greater than or equal to 2. And that is that. So for us, that's just leaving out this one. Okay, so that is the map and the filter. Now let's show you a little bit, because those aren't actually used that much. You won't see those used very often in Python, but what you will see more often is this list comprehension that I'm about to show you here. So the syntax for this is going to be like this. So you're going to have the expression here like that, and it's going to say for num in numbers like we have above. So this is the syntax. So it's going to have the expression, and then it's going to say for whatever value here in this list. So basically we're just mapping over every item in that. So if we were to use this, let's comment this out. Come down here and we'll say filtered, we'll just use that again, filtered nums like that. And then that is going to be equal, and we do our square brackets here, and we'll say num for num in numbers. So here we're not actually going to add anything for our expression because we're just going to map over these. So num in numbers here. And then right after this, we can add some sort of clause here. So here we're going to say if num here is greater than or equal to 2, just like we had for this filtered one above. And that is going to be finish off our clause. And then here we'll print out filtered nums. like this. So let's show you this whole thing right now. So we're going to save in our variable filtered nums here, and then we're going to have square brackets, and we're going to say num for each num in numbers in the numbers list. If the number is greater than or equal to 2, we'll return it, and then we're going to print that out. So let's see what that looks like. Go ahead and save that and run it. And again, we get the same values back. So hopefully that's relatively clear. This is going to be a syntax you'll see quite a bit with this list comprehension, probably more than the map and the filter and all those different things. All right, so in this video, we're going to be talking about Python tuples or tuples, or I think tuples. We'll go with tuples. So let's get right into it. I'm going to first show you a little function called the zip function in Python. So let's say we had a couple of different lists like this. So we got two name lists right here with some different values. Now, if we wanted to actually combine these two lists, we could go like this and go print. And we can say list like this, make sure we turn it into a list. And then we'll pass this zip function just like this, and then pass in the two different names. So names 1 and then names 2, like that. Now, when we run this, we can see we get these two different lists, and they're turned into tuples right here. So this is going to be what the zip function is going to do, and these are what tuples look like on the right. Now let's talk a little bit more about tuples. So the idea about a tuple is that it's going to be similar to a list, but unlike a list, it's going to be a read-only list. And the other thing with a tuple is that it's going to be immutable, so you can't change it. So we'll go and create a tuple, and to do that, we're going to go like this, and we'll say we're just going to do a number, and this is going to be our tuple that we'll use for this. Before we go ahead and actually use this, let's show you how we might convert a list into a tuple. So in order to do that, we'll just say tuple like this, and then we can pass in our list like this. So this will be our tuple, and we'll just assign that to test like this. And then if we come down here and we print out test like this, we'll see this converted into a tuple, hopefully. And we run that, and we can see up here, this has now been converted to a tuple instead of a list. So that is how you would do that. And again, you could do that differently with a string. So if we went in like this and said, came in here and we said Darwin Tech like that, and we save that and run that, you can see that this is turned into a tuple of each individual letter in our string right there. So those are how you would convert either a string or a list into a tuple. So like lists, we can work with tuples in a similar way. So let's just get rid of this for now, and we'll get rid of this for now, and we'll come down, and below this, let's just show you how we might get an item off of that tuple. So like a list, we can go like this, and we can say print, and we can say numbers like that, and then we can pass in a particular index. So let's just say 2 for that, and go ahead and save this and run that, and we get 2 back. And if we look up here, our second index 0, 1, 2 is the 2 from there. So like a list, you can do a lot of the same things as you can with a list in a tuple. So let's come down below this, and let's comment this out. And again, we can do like similar things, like we can say print, and we'll say numbers again, and we can go like this and say 2:4, and that will get a section of it. So if we run that, come down, and we can get from 2 and 5. So if we start at 0, 1, 2, and then we go 2 up until 4, which is the 5, and it won't include the 5th one right there. So that is very similar to how we might do lists. And then finally, let's just show you one more thing again. Let's comment this out, and we can do things like this, where we say if, let's see if we have a number in here. We got 3. So let's say if 3 in numbers, like that, colon, and then we'll just print out yes. So if the number 3 is in numbers, our tuple of numbers, then it'll print out yes. And if we run this, again, we get yes right here. All right, so that's about it for now for tuples. You will see them come up regularly often in Python, but you can just treat them like an immutable list, basically. So thanks for watching, and I'll see you in the next one. All right, so let's talk about swapping variables in Python. So traditionally, if you want to swap a variable, let's see what you might do. So you might have a variable a, and we'll set that equal to 1, and then we'll have a variable b, and that will be equal to 2, just like that. So what if we had these two variables, but we wanted a to equal 2 right here? So if we came down here, we might do something like set a new kind of temporary variable. So we could say c, and then if we set that equal to a, like this, and then we can come in and we can say a is equal to b, like that. And then let's print out a like this and save that. So hopefully this should be printing 2 for us. If we run this, we get 2. So now our a is equal to 2. But all this is a little bit contrived and a little bit unnecessary in Python because we have a better way to do this. So if we want to come here, Python, we've talked about tuples before. So in order to swap variables, we can do something like a comma b like this. And then on the same line, we can just go equals, and then we can go b comma a. Now this should swap our different variables for us. So if we come back here again and say a is equal to 1 and b is equal to 2, like we had that before, if we go ahead and save this and then print out a and copy that down and print out b like this and go ahead and save that. Now if we run this, we can see that these two variables have been swapped. We get 2 for the a and 1 for the b. So that's an easy way to swap variables in Python. And this works because this syntax here is the same as going like this. And this would be a tuple like here. So if we again save that and run that, we get the same thing right there. Now, that is how you might swap variables in Python. And you might also see this in terms of assigning multiple variables in a single line. So again, we could say a comma b again here, and that is equal to, say, 1 comma 2, like that. And this would be the same thing as doing this up here. And that is why we can swap variables in Python. So thanks for watching, and I'll see you in the next one. All right, so let's talk about sets in Python here. Now, what is a set exactly? It's a collection without any sort of duplicates. So in a typical list or something, you could have many duplicates, but in a set, you are not able to do so. The other thing you want to keep in mind is that sets are unordered, so you cannot access them like you may in some sort of list with like the bracket notation like that. So you wouldn't be able to get a certain item out of a set like you would in a list like that. All right, so now that we kind of have the definition down, let's show you how we might create a set. So let's say we have create set like this as our variable, and then we're going to use these curlies like this, and we'll just say 2, 4, 6 like that, and that is a set. So if we print out create set like that, go ahead and save that and run that, you can see we get our set here below. So that's basically how you would create a set. Let's copy this or comment this out below. Now, what if we want to transform a list into a set? So let's say we had a list like that there. Now you can see we have duplicates right here, so keep that in mind because that'll be important in a sec. So then we wanted to create a set out of this. So we can say new set like this. And this is just the variable name. There's no importance. You can call that whatever you want. And then we're going to use this keyword, which is set, like that. And then we're going to pass in the nums, which is this array or list in Python right here. So we're passing in that list to the set keyword. And then we can come down here and we can just print out that new set like that. And let's go ahead and save that and run this. And you can see we get this set back right here. Now you'll notice, like I just talked about, there's only a single 4 in there because there's no duplicates allowed. So that's one way to transform a list with duplicates into a set without duplicates, basically. All right, so we can also do unions with sets. So let's go like this, and we'll just say set union like this. So we have this. Let's comment this out right here, and then let's come down below here, and we'll just print out this set union like this and save that. Now, when we run this, we get these different values here. So any value that is either in this set here, this new set that we created, or this one will be printed. So that's all our different values here. And again, no duplicates. So we only have 1 4 instead of 3 right there. Okay, so that is the OR. Now let's get rid of this again. And if we come back down here, we can do other things as well. So again, like all the different functions, we can go and like this, and save that and run that. And that will give all the values back that are in both. So for us, that's just a 4 in both of these. So that is good. And then let's try some other ones. We can go the minus like this. So 1 minus the other. And we get back 2 and 6 here. So we have the 2 and 6. That is the only ones that are not this create set, which is right here, minus this new set right here. So that is that. And then finally, we have the little caret right here. So we can run this. So you can see we get back these values here. Now this is going to return either the values that are in one or the other, but not both. All right. All right. So hopefully that's helpful. Some different ways you might be using sets. Thanks for watching. See you in the next one. All right, so let's talk about dictionaries in Python. So a dictionary is just basically an object. So if you're used to JavaScript objects, that is what a dictionary is. If you're not used to that, basically we're going to have a key and a value pair, and that's what's going to make up your dictionary. So as usual, let's just actually show you how some of this works. So if we want to create a dictionary, we might do something like this. So what we have here is a dictionary. So we just have some scores, a key of names here, and then followed with a value for the score itself. So this is your key value pair for Python. So this will create a Python dictionary for us. The other way you can go about doing this is if we want to use the keyword dict, which is like this, that will create a dictionary for us too. So let's just show you that again. All right, so this is the second way you would create that dictionaries with this keyword here, dict. Okay, so that's kind of the basics of how you create a dictionary in Python. Now let's go and show you how we might get a value from there. So if we wanted to get a certain value, we can go like this and say scores like this. And then we can actually do this bracket notation here. So square brackets, and then we pass in the key. So for us, say that's Darwin like this. We can go ahead and save that. And when we, or let's actually print that out real quick. So we go ahead and print that, we get 10 over here on the side. And that is the value to the key of Darwin that we're accessing right here. All right, so what else can we do? We can go scores like this, and then we can set it to a different value. So say we wanted to go and set Darwin there. So we say Darwin again. And now instead of keeping it at the same value, we wanted to set it to 11 like this. Okay. And then we can come down here and we can just print out the scores again like this. Go ahead and save this. And we come back up here and print that. You can see now this Darwin has a score of 11 instead of 10 like before. So that's how you might change a value like that. Now, what if we wanted to do something different, like add a completely new key that's not in here? So we can do that by just coming down here, say scores again, and then we can add it. So let's say we'll call it max like this, and we'll just set that equal to 15. And again, we can run this. And in here, you can see max's 15 is right there. So that is looking very good. Now we can add a value with this, right? So that's good. But what if we want to delete a value? Well, that's where this del keyword is going to come in. So that's what we're going to use for that. And we're going to say scores again. And again, we'll pass in the same thing as Darwin. And go ahead and say that and print this. And now you see this Darwin is nowhere to be seen. So it's gotten rid of the Darwin key value pair with this del keyword. So that is how you're going to use that. All right, so that is most of the different stuff we're going to want to use with dictionaries. So we can also do stuff like checking if a certain key is in an object, or sorry, a dictionary. So we can say if like this, and we can say Darwin like that. And then we can say in. So this is the same thing you'll see in lists in Python, right? So we've looked at sort of something like this before. So if it's in the scores like that, so we'll just print out true if it's there. So we'll just say true. Go ahead and save that. Now right now we're deleting it, so it shouldn't be in there. So let's just make sure that works. We print that out. We get nothing because we don't have an else clause. So now let's comment this out and run it again. And now it should be in there. And it is right here. You see the true coming through. So that is good. Kind of the last thing we should just cover is looping through a dictionary. So we can go like this and say for name in scores like this. And then we're just going to print out. And we can print out the name just like this. And this will give our key. So let's run this. And you can see we get these different keys right here. So that's great, but we might actually want the key value pair. So if we were to need that, we can come in and we can say scores like this at name. So it's going to loop through and show all the key and the values. And if you see, we have these key value pairs right here when we do that. So that is dictionaries in Python. See you in the next one. Today we are going to be talking about the unpacking operator in Python. So let's get into this and show you how this is going to work. So imagine the scenario where we have some sort of list. So here we have a list of names here, Darwin, Sally, and Bert. And what we want to do is print out those individual names. Now, how might you do that? Well, you could loop through these different things. It's an iterable, so you could do that. But luckily with Python, you have something called the unpacking operator, which is just a star like this. So if we wanted to go like this and say print, and then you do the star, and then we went names like this, go ahead and save that. And now when we run this, you can see that we get these three names individually. If we didn't have the star, we would print these out in the array, just like this. So that is what the unpacking operator does. Now let's try to see a few other examples of why this might be useful. So if we come down here, we can go like this. We can say name like this, and we'll say that is equal to Darwin like that. Now, any iterable, the string is an iterable, a list is an iterable, literally anything that's an iterable, you can use this unpacking operator. So we got name, Darwin as a string, and if we wanted to unpack this, we can just go like this, and we can say print, and we'll go like this again, and say name like that. And we can come down again. Let's comment this one out for now. Save that and print this out. You can see we're getting each individual letter here. These are the space shows that it's actually an individual letter and not just the name altogether. So that is kind of useful, but there's a bunch of other stuff we can do. So let's say we had two lists. So we got list 1, and that's going to be equal to just an array here. And we'll just go 1, 2, 3, 4. Like this, and then we'll come down here and say list 2, and that'll be equal to another array. All right, so we have our two lists here. Let's correct that spelling right now. And then we can come down below this, and with the unpacking operator, we can combine these two very easily. So what we can do is we can come down and say combined like that, and that's going to be equal to, and we're going to have an array here. And then inside this array, we're just going to say star like this, and we'll say list 1, and then we'll go comma, and we'll go again star, and then say list 2. So this will unpack both of these and combine them. So that can be quite nice and useful. So let's come down below here and we'll just print out combined here like this. Now let's comment this one out too so we don't get too jumbled here. Run this again and you can see it merges both of these lists together and combines them. So that is a nice little feature of the unpacking operator. So if you're familiar with JavaScript or anything, that is kind of like the ... spread operator that is common in JavaScript. It's basically the exact same thing, I believe. Now, we can do this with any sort of iterable. So you could do it with anything that you can loop over. So any sort of iterable. Also, one thing to note is you could do this with dictionaries also, but the only difference is that you're going to do a double star instead of a single. So that is the unpacking operator. Hopefully that was useful. Thanks for watching. See you in the next one. All right, so let's talk about error messages and exceptions in Python. So we're going to go over how you can handle exceptions in Python. So let's jump right in. So if we have something like this where we say print and we'll give it a number. So say 5 and we'll say plus, and we'll just do a variable we haven't assigned yet. So let's say we have a variable called num we haven't created yet. We're getting an error right here, but let's see what happens if we try to run this. So you see when we run this, we're getting this error down here, and it's a name error. It says name of num is not yet defined because we haven't created that. So what we want to do is show you how we might handle these different exceptions. And there's all types of different exceptions that might come up. So we'll show you a few of them and how you can maybe handle them. So in Python, let's come up here first and we'll just comment this out. And then we'll come down below. And what we're going to use to handle these exceptions is something called a try block here. So we're going to say try like this. And then inside of this, we're going to do our block here. So we're going to say, we'll go variable and we'll say a, and that's going to be equal. And we're going to do an input here. And we're going to say enter a number. Now we're going to have to turn this into a number. So we'll say int like this. And then we can come down below here and or beside here, and we'll say input like this and here, and we'll say enter a number like that. And then we'll come in here, and below this, we're just going to print out a. So for this try block, we're going to say enter a number. Now we want it to make sure it's an integer. So say we enter something that's not an integer, this is going to throw an exception here. Now, in order to handle that, we're going to come back here and we're going to say except like this, and we're going to say a value error because we're going to pass in the wrong value to test this out. So a value error like this, and then below this, we're just going to print out what we want to show. So we're going to say print out, and we'll say, sorry, that was not a valid number like this. Okay, now we can go ahead and save this and see how this works. So theoretically, if we put something into the box right here that is not a number, we should get this back out. So let's run this. And we're going to ask us to enter a number because that's what this input here is. So let's say not a number like that, and we enter that, and we get back this value, sorry, that was not a valid number. So that is how we are going to handle different errors with this try and except. Now, the cool thing with this except here is right now we're passing a value error, but there could be a bunch of different types of errors that we could handle. So if we come down here, we could say chain these on, so we can say except again. And here we might want to do something called like a name error. And you can look up all the different errors that we have. There's a bunch of them in Python. So a name error, and then we might say print name not defined like that. So this would be used if we passed in something like a num that hadn't been defined yet or something. That's where they would print this. So that is that. And then finally, if you come down below here, you can just add an else clause here, and it'll just print out whatever you want. So we'll actually do this one. So we'll come down here and we'll say print, and we'll just say no errors thrown like this. So now we come here, let's clear this out. And then if we run this again, gonna ask us for a number. Let's put in 3 here, and it'll just pass out no errors thrown. So that is how you are gonna handle different exceptions in Python. Now you can also go and throw an exception. So let's show you how you might do that. Comment out this, come down below here. All right, so let's define something here. So we'll say def, and let's say get num, like that. And we'll pass in a number here. And then we'll do an if statement. So if the num is less than, let's say 2, we'll go below here, and then we'll raise an exception. So we do that with this raise keyword here. So we'll raise, again, a value error like that. And then we'll just pass in here number cannot be less than 2. Okay, so that is going to be our what we need there. And then finally, we can just return num if it's good. So if the number is less than 2, when we pass in to this get num here, then we're going to throw the exception. So let's try it out. So let's come down below here, and we'll say print, and then we'll just go like this, and we'll just come in here and say get num like that, and then we're going to pass in 1. So this should be good right now. So go ahead and save that. So the value error here, number cannot be less than 2. So we're passing this 1, and this is what it's checking. So it's going to throw an error. Now, if we pass in a valid value, so something greater than 2, and we run this, we should get no errors here. So that is what we are getting, just passing back the value, and that's this returning of the num there. So that is how you can throw an exception. Now, you don't usually want to do this because they are quite expensive in Python. So this isn't something you're going to be reaching for a lot, but it is good just to show you how that might work. Anyways, that's it for this video. Thanks for watching. See you in the next one. All right, let's talk about classes in Python. So a class is basically just going to be what's often referred to as sort of a blueprint for creating new objects. I'm sure you've worked with some sort of classes in other programming languages, so we'll skip over kind of the basic definitions and show you how they work in Python here. So in order to create a class, we're going to use the class keyword. So we're going to come in like this and say class. And let's say we wanted to create an animal class. So we'll say class animal like this. And like our other Python syntax, we'll just do the colon there. And then we'll come down below here. And now we're going to add a method that you'll have basically every class you write. So in order to write a method on your classes, we're just going to define that. So def, and we're going to go underscore underscore init like this. And this is the syntax you're going to use basically every single time you write a class. Now, the first argument for this init method here is going to be self like this. Now, self is just going to reference the current object, and that's going to be the first argument in basically every method you write inside of your classes. So we'll do that, and then let's add a couple more things that we might want for our animal class. So something like, let's say we'll have a weight and we'll have a species like this. Okay. So now we have a few things. We'll add our colon here and finish off this method here. Now we have to reference self here. So we're going to say self.weight like this. And then we can set that equal to whatever we want. And we're going to set that equal though to whatever we pass in here. So weight. So this is going to be equal to this. And then we're going to do the same self.species. And this is going to be initially set. So we could set this to something different if we want, but it makes most sense often to just set it like this. So species like this. Now we're going to come down here below this, and here we're going to create another method, and we're just going to call it create. So def create like this. And inside here again, we're going to pass in that self argument just like before. Then come down below here, and we're going to print out here. We'll just say print. And we're going to do an F string, which we went over in other video. And we'll just say this. And then in here, we'll say self.species like this. And then we'll just say ways. And then we will do another curly braces here. Except we're going to close this off, so make sure you do that. And then we'll do another curly braces here. Self dot weight like this, and close that off. And then we'll just finish this with just LBS to give the pounds there. Okay, so that is what our F string is going to look like there. Now, if we come down, we can come down below this here. All right, so then we can come down here. I'm going to create a new instance of this class. So let's say we want to create a dog. So we'll say dog like this, and then we'll say animal like so, and we'll pass in whatever we want. So we can have a weight and a species. So for the weight, we'll just say 30, and then for the species, we'll say dog like this. And then we can come down and make sure we do an equals here. And then come down below this, and we can just say dog.create like this. Okay, and we can call that. And right now we're getting this error animal is not defined because this is inside the scope of our class. So come back here, make sure this is not inside the scope, and you should be good. Go ahead and save that, and then we can come and run this. Now we get this here, this dog weighs 30 pounds. And again, we could just pass in something different here. So the main takeaway from this video, I think, is this definite method that you're going to use basically on every single class you create. So this is basically your constructor function here, and you're just going to reference self, which is a reference to the animal object here. All right, so that is how you create classes. We're going to have much more in future videos about classes, but this will get you started in how the syntax looks for that. All right, thanks for watching. See you in the next one. All right, so today we're going to be talking about class methods, and sometimes you'll hear these referred to as factory methods. So we're going to take a look at these. This is where we left off last time. We just created a little class here called animal. We're initializing it here, and then we have this little create method. And basically when we run this, you'll see we get printed to the screen this create string like this. We're passing in 30 and dog, and that's what we're getting right here after calling dog.create. So that's where we left off, but now we want to talk about kind of another way you might handle this. And this is going to be with a class method. So the idea of these kind of factory methods here, they're going to provide us with another way to create an object, basically. And they do this without kind of exposing the logic to the client. So instead of passing these values in here, we're going to add them up here inside of our class. So let's go ahead and just show you, because this is going to be pretty confusing unless we show you an example. So let's come up here, and we're going to come in below this, and we're going to create a class method here. Now, to make a class method, we have to use a decorator. So a decorator is just going to be like this, and we're going to say class method like that. And then below this will give us access to everything we need. And basically, we haven't gone into decorators before, but basically they are going to extend the behavior of the class. So let's create something. We'll just call it def, and we're going to say basic like this, and then we'll pass in CLS. Now, CLS isn't anything special. It's just a convention, and it's going to stand for class there. So we'll have our typical syntax here, and then all we're going to do is return, and we'll say CLS, and then we will say the same thing as below. So we'll say 30, and we will say dog. So this is going to be our basic method that we might run a bunch of times. Now, obviously, this could be anything else. Now, in order to use this, instead of passing in these values down here, now we can go like this, and we can say animal.basic like this, and call that, and then call create below. So this will set to dog still, and we'll call animal.basic, which will run this. So now when we save this and run this, you should get the same result. And we do right here. Dog weighs 30 pounds. So that is a little introduction to class methods and the idea of factory methods in general. There's a bunch more we can do with them, but this is a great way to create an object in Python. So thanks for watching. See you in the next one. All right, let's talk about how inheritance works in Python. So basically how this is going to work is any class can be a parent class. So the syntax is basically going to be the same as creating any other class. So let's get right into this and show you a little example here. So imagine we had a class, and we'll call that person. And let's say we have a little method on here called greeting. And we pass in self here like always. And then below here, we're just going to print out a greeting, and it's going to say hello. So that's our little method on here. and that is going to be our original class. Now, what we can do to show inheritance here is create another class, and we'll call this one John. And then right here, we're going to pass in the person class here like this. And now it's going to be available within our John class right below. So we can go like this and give it say def name, and we'll just go like this. And we can just print out I'm John like that. Okay, so it's got its own little method on there, which actually we won't be using here. So then we can come down below here. So let's initialize this class. So we're going to say greet. So we'll say greet, and that'll be equal to person like this. And we'll just call that like here. We'll say greet dot greeting like this. All right, so then if we save this and run this, you can see on the side here we get hello, which is what we'd expect because we're printing hello on this greeting call here. Now, what we have here, because we've passed in this person class here, it's going to inherit all the attributes on this person. So now we can actually go like this and say John like this. And now go ahead and save this. And we still get this hello printed to the screen. So what's happening here is John is inheriting all the methods off this person class. And that's why we have this dot greeting available to us. So that is basically how inheritance works in Python. Very straightforward, very simple, and something that you will use a lot within the language. So thanks for watching, and I'll see you in the next one. Let's talk about method overriding right here. So this is the class we had in our last video here. We got a person class, and we got the class of John right here, which is inheriting this person class. Now, as you know, because we're inheriting right here, this person class onto this John class, we have access to this greeting. So when we run this, we're going to instantiate it and then run it right here. You see we get the hello coming from this person class and inherited into this John class. So that is all well and good, but we can also override the various parent classes here. So right now we're inheriting this greeting from this person class right here, but let's come up here and we'll come in and we'll say def, and we can say greeting, and again passing self like this. And if we go like this, and now instead of print hello, let's just say print hey like this. Go ahead and save that. Now we're going to override this inherited class above. So if we run this time, you can see we get hey instead of hello. So that is how you override a method in Python. One note is that with inheritance, you really got to watch out not to inherit too many levels deep, because this logic can start to get complex when you start inheriting from one class to another and going down the tree. So it's best to keep them relatively limited in scope.